Although few of the inhabitants of this world, animal or human, have the exact same size, similarities exist in many situations. To find the height of a building, the height of a person, and the length of the shadows of both can be used. To build a city, the specifications can be projected from the construction of a scale model. Real-life situations involving inequalities are seen daily with police officers and their radar equipment enforcing the speed limits and restrictions posted for the use of express lanes in various businesses. Hello, welcome to Me and My Shadow. In this program, we will explore the idea of similarities and all of the concepts surrounding it, as well as talk about inequalities. Our first task is to take a look at similarities. To do that, let's watch some students taking measurements of their shadows and of their height.
Jaquanta, I wonder what is the length of this light pole?
I don't know, maybe we can measure the shadow and then measure your height and your shadow and put in a proportion and we can find out from there, don't you think?
Well, okay. Jaquanta, from that end to this end, it came to 120 inches. So you start right there and I'll hold this right here and you come down and do the measure from there.
And let's see. From where we left off to the base of the light pole, it will be 97 inches.
Okay, so altogether that should, from the base of the light pole to the tip, it should be 217 inches.
So now we're going to measure you and your shadow.
Okay.
Now we're measuring Chevalier's height. Chevalier's height is 66 inches. Okay, the Chevalier, the length of your shadow is 91 inches. So we're gonna put your height and the length of your shadow in a proportion with the length of the shadow of the light pole, and we're gonna see if we can figure out the height of the light pole.
And now it's gonna measure Jaquanta's height. Jaquanta is 63 inches. Okay, Jaquanta, let's see. The length of your shadow is 83 inches. So we're gonna take the length of your height and the length of your shadow and put it with the length of the shadow of the light pole and see if we can put it in proportion and get the height of the light pole. What you think? Okay.
The students compare the length of their shadow with the length of the shadow of a light pole. This comparison is called a ratio. A ratio is simply a comparison of two numbers by division, as demonstrated on the screen. You have 91 inches divided by or over 217 inches and 87 inches over 217 inches. A ratio is simply nothing but a fraction. Now we'll demonstrate the ratio of the student's height to the height of the lamp pole. Since the height of the lamp pole is unknown, we're using x to represent it. So the ratios are 66 inches for the height of the student over x and 63 inches over x. Since we're dealing with similar ideas, such as the height of the lamp pole and the student, and the shadow length of the lamp pole and the student, if we draw a line from the top of the light pole to the end of its shadow, then from the student's head to the end of her shadow, you'll see we've created what's called similar figures. We have two right triangles. Similar figures are figures that have the same shape, but not necessarily the same size. From the comparison of our shadow lengths of the light pole to the students, we can develop what's called scale factors. The scale factor of the shadow length of the light pole to one student is approximately 2.385, and the other scale factor of the light pole to the other student, according to the information that they collected, is approximately 2.495. Now we'll collect all of the information and put it into a chart to begin developing a proportion to find the actual height of that lamp pole. If you'll notice, we've set up a chart. In our chart, we have the shadow length and the actual height of the objects that are being measured, which are students and the light pole. To enter the information we've collected, one student has a shadow length of 91 inches. The light pole shadow was 217 inches. The student's height that had the 91-inch shadow length was 66 inches. Since we do not know the height of the flagpole, we'll use a variable x to represent that. The organization of the information from the table we just viewed leads us to set up the following proportions. The student shadow over the light pole shadow will equal the student height over the light pole's height. A proportion is simply two ratios or fractions set equal to each other. For practical purposes, I'll use A to represent the student shadow. I'll use B to represent the light pole shadow. I'll use the letter C to represent the student's height. I'll use the letter D to represent the light pole's height. Now, since we want to know the height of the light pole, to solve for that, we'll need to multiply both sides of our equation by 1 over c to eliminate the c in the numerator, leaving us with a over bc is equal to 1 over d. If we simply invert both sides of the proportion, we result in having the light pole height equal to bc over a. BC over A is equal to D is called a literal equation. A literal equation is an equation involving two or more variables. Now, if we take the numbers the young ladies collected earlier and substitute them into the literal equation we just looked at, we'll end up with a numerical proportion with only one variable. A numerical proportion can be solved using cross products. Cross products are, in a proportion, the product of the numerator of the first ratio and the denominator of the second ratio, also the product of the denominator of the first ratio and the numerator of the second ratio. The results of these products are equal. Now let's take a look at the proportion. We've got 91 inches over 217, which are the shadows of the student over the shadow of the light pole, is equal to the height of the student, 66 inches, over x, which is the height of the light pole that we're looking for. To solve this, using cross products, x times 91 results in 91x. 217 times 66 equals 14,322 inches. To complete this, since we multiplied to have a 91x as our product here, we'll simply divide by 91 to remove it and have the x left by itself, causing us to also divide the other side of the equal sign by 91. When we divide 14,322 by 91, we get approximately 157.4 inches as the height of the lamp pole. Now, so much for the idea of proportions. Let's take a look at inequalities. If we would simply take the information we collected from the light pole and the students, the information we've learned about ratios, proportions, and similar figures, we can calculate the length of the third side of each triangle by using our scale factor. If you'll take a look at the triangles we have, this triangle represents the height of the student and the shadow length of the student. In the larger triangle, we have the shadow length of the light pole, but we do not know the height of the flat light pole. To find that out, we'll use scale factors. The third side of the triangle for the student can be found by using what's called the Pythagorean Theorem, because if you notice, the student and her shadow formed what's called a right triangle. Therefore, the length from the top of the student's head to the end of the student's shadow would result in being 112.14 inches using the Pythagorean Theorem. Using our scale factor of 2.385 for this particular student that we found previously, if we simply take our measurements, multiply each one by our scale factor, we'll end up with the height of the flagpole and the hypotenuse that that triangle made, resulting in 157.4 inches for the height of the flagpole when we multiply 66 times 2.385 and 268.074 inches for the hypotenuse of that right triangle. Now, we know from our geometric properties that the sum of any two sides of a triangle will always be greater than the sum of the third side. Hence, from our previous triangles, we can see having B plus C greater than A plus C greater than B, and A plus B greater than C. From the data we previously collected, I'll substitute in the height of the student for A, the length of the student's shadow for B. Since we're solving for C, we'll use X to represent that. Solving each inequality for X, we end up with, for the first one, X is greater than A minus B, causing us to result in X being greater than negative 25. Next, we have X is greater than B minus A, resulting in X is greater than 25. Then we have X is less than A plus B, giving us the result of X is less than 157. From that, we can develop what's called compound inequalities. Compound inequalities are two inequalities that are joined by the words and or are. In our case, we have X is greater than negative 25 and less than 157. The number line that represents this will have open circles, since negative 25 and 157 are not part of the solutions. Open circles that are joining, since X is greater than, going this way, negative 25 and less than 157. The next compound inequality we have is X is greater than 25 and less than 157. Again, the same type of number line to represent this inequality exists, since X is greater than 25 with the line going to the right, and X is less than 157 with the line going to the left, ultimately meeting. In the information we just viewed, we saw developed what's called replacement sets. Replacement sets are the sets of possible values for the variable in an inequality. The replacement set for our first compound inequality comes from this particular area. If we take any number from this area in the number line, substitute it back into our first inequality, we'll end up with a true statement. If we take any number from our second number line, that is, numbers between 25 and 157, put them in our second inequality, we'll end up with a true statement. The solutions of inequalities are any value of values of a variable in the inequality that makes the inequality true. If in our data collection we had been given two students with equal heights, we could have finally resulted in having equivalent inequalities. Equivalent inequalities are inequalities that have the same solution sets. Now, we finished with the idea of inequalities, and we've also explored proportions. Let's review a little bit about what we've learned. We've talked about a ratio. We've talked about similar figures. We've talked about the scale and scale factor. We've talked about literal equations and cross products to solve proportions. We've also talked about compound inequalities, replacement sets, solution of inequalities, and equivalent inequalities. Now, get ready to rock and roll with your teachers and to reinforce the information that we've had in this program by performing some of the skill tasks your teachers will acquaint you with now. Thank you for your attention and have a good day.